Hello everyone, welcome back to the channel Knowledge for You. Today I am going to tell the most important question from the unit amplifiers. So this is a unit of electronic devices subject, and this subject is common for EEE, ECE and instrumentation branch. So let's start. The first one is define amplifier. An amplifier is an electronic device which increases the strength of a weak signal. Here strength refers to either voltage or current. So it's an electronic device which increases the strength of a weak signal. Next question is define faithful amplification. The process of increasing the strength of a weak signal without changing its original shape is known as faithful amplification. See here, the process of increasing the strength of a weak signal without changing its original shape. That means if I apply a sinusoidal waveform, to an amplifier, then it should give the same shape with increase in amplitude. Okay, that's nothing but faithful amplification. The process of increasing the strength of a weak signal without changing its original shape is known as faithful amplification. The next question is state the necessity of proper biasing in transistor amplifier. Here biasing refers to applying external voltage. So the proper biasing of a transistor is necessary to achieve faithful amplification. To achieve faithful amplification, proper biasing of a transistor is necessary. Here proper biasing means the input junction, nothing but base emitter junction, is forward biased, and the output junction, that is collector base junction, is reverse biased. Next, list different biasing methods. So the various biasing methods which are discussed in the diploma subjects are the fixed bias, and next base bias with collector feedback, base bias with emitter feedback, and the last one is voltage divider bias or potential divider bias, also known as universal bias. Out of all these biasing methods, the most preferable one is voltage divider biasing method. And the next question is define operating point or Q point. Q point is nothing but quiescent point. So operating point refers to it's the intersection of DC load line with output characteristics of a transistor. The intersection of DC load line with output characteristics of a transistor. So see here, on x-axis we are taking output voltage VCE, on y-axis we are taking IC, output current. This is the DC load line we have, and this is the output characteristics of a transistor. So this intersection of the DC load line and the output characteristics of a transistor is known as Q point, and this point is in the form of x comma y, that is VCEQ comma ICQ. X axis we have VCE, y axis we have IC. Next, what should be the location of operating point to achieve faithful amplification? It should be located exactly at the center of the active region. It should be located exactly at the center of the active region to achieve faithful amplification. Faithful amplification means increasing the strength of a weak signal without changing its original shape. So already we have discussed that transistor operates in three regions. First one is active region, next is saturation region, and the next one is cutoff region. So out of these three regions, in active region, transistor functions like amplifier. And to obtain the faithful amplification, the location of the operating point should be at the center. And the next definitions we have, define the terms gain and bandwidth. So usually gain refers to output by input. So it is defined as ratio of output electrical quantity to the input electrical quantity. Output electrical quantity to the input electrical quantity denoted by letter A. So if it is a voltage gain, it is designated as AV equals to V0 by Vin. If it is current gain, AI is equals to I0 by Iin. Power gain, AP is equals to output power by input power. And the units of gain is decibels, represented as dB. See here, another question from this is express gain in decibels. If the question is asked in decibels, then in that case the formula becomes AV, that is voltage gain, is equals to 20 log base 10 output voltage by input voltage. Next, current gain 20 log base 10 I naught by I in, and power gain is 10 log base 10 output power by input power. So all these are in dBs. And next definition is bandwidth. So bandwidth refers to the range of frequencies. It is a range of frequencies over which gain falls to 0.707 times of maximum gain. Range of frequencies over which the gain falls to 0.707 times of maximum gain is known as bandwidth. So next we have, so this diagram you have to draw whenever the bandwidth question is given. So on x-axis we are taking frequency, on y-axis we are taking gain. So this is the usual, this is a general graph of gain versus frequency. So this is the lower cutoff frequency f1 and this is the upper cutoff frequency f2, and from this the bandwidth is given by difference between upper cutoff and lower cutoff, that is f2 minus f1. And the next question is list different types of coupling methods in amplifiers. So the various coupling methods are RC coupling, that means resistor capacitor coupling, LC coupling, inductor capacitor coupling, transformer coupling, and director coupling. And the next question is why do we use the coupling methods? Coupling methods are used in case of multi-stage amplifiers. In multi-stage amplifiers, coupling methods are used to connect one stage with the another stage. To connect one stage with the another stage, in between them we use the coupling methods, and these are the various coupling methods. So next we have define the terms feedback and feedback factor. Feedback means taking the fraction of output back to the input. If it is my amplifier, if it is my input and this is output, then taking the fraction of output and giving back to the input is called as feedback. So feedback is of two types, positive feedback and negative feedback. Usually positive feedbacks are used in oscillators and negative feedbacks are employed in amplifiers. Next, feedback factor. So feedback factor, nothing but here we have the feedback network. So it is a ratio of output of the feedback network to the output of amplifier. Ratio of output of the feedback network to the output of the amplifier is called feedback factor, denoted by beta. Denoted by beta. So output of the feedback network to the output of the amplifier. So if we draw a diagram, so here we have input, amplifier, output, and here I have the feedback network beta. So this is the feedback output, this is the amplifier output. This is nothing but amplifier. Explain the effect of feedback on gain, bandwidth, and noise. This is the 1 mark question as well as 3 mark question. So usually the effect of negative feedback on gain is the gain decreases. The gain of the negative feedback decreases by a factor of 1 plus A beta. So it will be AF is equals to A by 1 plus A beta. Where AF nothing but gain with feedback, A is gain without feedback, and A beta is the loop gain. So beta is the feedback factor. Next we have bandwidth. The bandwidth of the negative feedback increases. That is, bandwidth with negative feedback is equals to bandwidth into 1 plus A beta. It increases by a factor of 1 plus A beta. So here the lower cutoff frequency it decreases and the upper cutoff frequency increases. So whenever it is decreases, we have to write that factor in denominator, and if it is increases, we have to multiply it with the original frequency. And the last one is noise. The noise of negative feedback decreases by a factor of 1 plus A beta. That is, noise with feedback is equals to N by 1 plus A beta. So this is the most important 1 mark, and few are the 3 mark questions from the topic amplifier. So if you like the video, please like, share and subscribe to my channel. Thank you.